In this video tutorial, we are going to have a look about how we go about converting floating point numbers, but this time we're going to go from a decimal number into a binary number. So with this, we also need to understand the concept of normalization. So I'm going to briefly cover that as I sort of work my way through this tutorial, and there'll be some questions to sort of have a go at practicing first of all as we go later on. Now the numbers I'm actually going to deal with, I'm not going to deal with particularly complicated numbers. You wouldn't necessarily be expected to in the exam either, but it's worth just kind of like using these as your reference ones to sort of start off with. So to begin with, what we're going to have a look at is, let's take the number, let's take a nice steady number like 13.75, and let's say we want to convert that into floating point number format. Well, first of all, what we do is we write out the number in its sort of fixed point form. So 13 is going to be written as an 8 and a 4, a 2 and a 1, 0.75. Okay, and we could write more zeros afterwards, but we don't really need to. Now, what you've got to imagine with a number like this, and it's actually, I've written it out quite badly to be fair, so I'm just going to rewrite this. What I want you to imagine is that on a number like this, we actually have got an infinite number of zeros in front of us. Like we could have, those could be the placeholder values for 1, 2, 8, 64, 32 and 16. And so to actually write out 13, that would be the value 13, as would be the value 13 without the 4 bits at the front. And then we place after the decimal point, if we put our 7, 5 in, and then we could have some following zeros as well. Doesn't really matter. What we're trying to do though in floating point format is we're trying to get our number what we call normalized. Now a normalized floating point number is a number that keeps or maintains the precision of the number while allowing you to then put it into this floating point format. So what we've got to do is we've got to work out where we're going to put our decimal point. Now, we know that in our mantissa, a positive value always begins 0 point. So we need to move our decimal place to a position where our number is going to start with 0 point something. Now, we could move it to one place to the left-hand side, and we could place it just here. So that then the number would be 0.1110. The problem of that is, and some of you will have realised this straight away, is that we've then lost these two values of 1 just here, and so therefore we've lost the precision of the number, because actually what then happens is we don't have a number of 13.75, we end up with a number of 1.75. So when we move our number, well, actually what we want to do is calculate how many positions we need to move it over, so the whole number is recorded or kept, and it becomes 0 point something. So in this case, we're actually going to move 1, 2, 3, 4 positions over to the left-hand side. So to record our mantissa, what we do is we're going to write a 0 point because it's positive, because this is this first bit just here, and then we're going to write out the number that we've been given just there. So it's 1101.11, and then I can just fill the rest of it with corresponding zeros. My exponent therefore is 1, 2, 3, 4, so it's a positive shift, because although it's kind of going to the left, and the examples that we've looked at from converting from binary to decimal, left means negative, it's a positive shift because it's going from right to left. It's therefore going to be 4 like so. Okay, so it's over to you guys now. I'd like you to have a go at converting for me the number 8.0625 into floating point format. Pause the video now, have a go, and then I'll take you through the answer. Okay, so first of all, we're going to write out the binary value for 8.0625. And it's not a half, not a quarter, not an eighth. I didn't give myself enough room here, never mind. So it's like that, isn't it? It's a half, quarter, eighth, and it's a 16. So 8.0625 is written like so. Now what I need to do is I need to move my decimal place to the left by an appropriate number of places. So I'm going to go 1, 2, 3, 4 here, because my normalized floating point number is going to begin 0.1. Okay, always begins 0.1, and then I'm going to write this out here. So it's going to be 1, 2, 4, 6. 1, 2, 3, 4, 5, 6. 1, 2. That's correct. And then 1 and then 0 on the X has got nothing to do with that. And then my 1, 2, 3, 4 is going to be written as 0, 0, 0, 4, 2, 1. And there is my final answer for the normalized floating point version of 8.0625. So I hope you got on all right with that. Let's deal with them. In fact, that's going to do for part 1. And then we'll switch over to part 2, looking at some negative values very shortly.